Welcome back to the DB Garage. Today, we won't be working with the usual projects. Instead, we're going to take some time to film something a little bit different for you, focusing on some of the daily activities that come up and the various problems I encounter along the way. Now we'll explain in a little bit more detail what we have planned for today. Today we're going to clone this engine computer as well. Unfortunately, it's been sitting in water and it's dead. We attempted to fix it, but unfortunately it was not successful. We have to take care of that. Today we also need to repair this BMW E60 navigation system. Usually when the car is started, only the BMW logo appears. It is likely either a software or hardware related problem, so we need to look into it further. This dashboard has a completely dead onboard computer, and the needles are frozen in their current positions, stuck at 70 degrees and a third of the tank. I can only assume that someone was tampering with the mileage or something similar to that, because otherwise, why would anyone even bother to take this apart? Of course, it is quite clear that the unit is broken. Then we also have a mechatronic unit from an Audi A4, a 2004 convertible coupe, which is truly a beautiful car. The magnets and valves aren't shifting as they should. With these specific units, it's quite common for the internal mechanics to have some issues. So what we'll do is take it apart, open it up and check to see if everything inside is still okay. Next, moving over here, we have one engine computer as well. Right here, we'll be starting stage 1. Over in this area, we've received a lot of items by mail. Here we have an Audi A6, I believe it was an Audi A6, and for this particular one, we need to disable the AdBlue system. Yesterday, we worked on this particular project. All of that equipment needs to be carefully picked up from the site. We successfully cloned the device, that is, the lock itself. We also provided him with another functional key, and we even made a specialized emulator for him. Sitting right here on the table, we have our very next potential candidate, which happens to be... This is an E-Class, the W212 model. When the weather gets hot, the engine just won't start at all. It seems like either it's the steering lock, the lock itself, or perhaps an ignition issue. Unfortunately, I just got a single key for this particular lock, and I did not get the steering lock module exactly like I did over there. So I have to see what I can do without it. It would be best if I got the entire complete set, because then I could test it out properly. Alright, moving on to the next one, we have a BMW F45. The car will not start up. We need to take a look at what's going on with it, but as you can see here under the microscope, it's already been soldered. That's where its EEPROM is located. And you can see that it's already been soldered unprofessionally. We need to see what's going on with that. Alright everyone, now we're going to start diagnosing the electronic ignition switch for this Mercedes E-Class W212. There is a recurring problem where, after starting the car a few times, the vehicle simply no longer reads the key at all, and then unfortunately it won't start anymore. You actually have to wait for a few hours to pass, and then it suddenly works again. So, what could the root cause be? It could be a fault with the key itself, of course. It could also be the ignition switch unit, or it might even be the specific control module for it. This is the steering column lock, which is also known as the ELV system, as the Germans call it. The car won't start at all, and that steering lock module is a bit tricky to remove. To get to it, you have to take off the airbag, the steering column, and the steering wheel. Basically, everything has to come off. It is quite complicated, especially if the unit is already locked. In that case, you actually have to drill right into it just to unlock the steering wheel at all. That is exactly why, for now, we only have this one single key to use. And the car lock actually has a set of 2 separate keys, but unfortunately the man is away on vacation at the moment. He is currently staying in Turkey and has the second physical key with him, so for now we only have the lock and this one key. If needed, we will make a second key, or we will make an entirely different plan. An emulator. This specific electronic emulator is designed specifically for that particular vehicle model for the steering column lock. One of the most significant advantages about this simulator is that it can, for example, simulate itself. For instance, if the original module is functioning correctly, but when you switch over to the unit, then the module has to be connected. And then it actually reads data from the module. So since it's not there, we'll have to set it to 0 so that it simulates by itself that the module is present and that the module is working properly. Basically, this is one such module. They really have a lot of different problems with this specific model, the W212 and the W204, and for example, this one is locked. And now, for instance, it can't be removed from the steering rack, so it wouldn't be a bad idea to drill a small hole here, and that's where the gear is. And with a small flathead screwdriver, you open it up and very carefully turn that gear manually so you can unlock it here, because it simply cannot be taken out of the assembly. There's a screw here, a bracket, and there's another screw over there. You can remove the screw, but you can't pull it out past that metal bracket because it's locked tight. And there are really a lot of different problems with this. It can be repaired, it certainly can be. First, you need to install an emulator. This specific device is the part that locks the steering wheel, for example. For this entire process, we will use a testing platform that I have available right here. IMK3 or something like that was the name of a company from Dubai, I think it was. This thing costs around 400 euros, but it's actually really top notch. It simulates that the car is here with us. And we're going to use the professional Autel EM608 Pro. Also a good device, but a bit too slow. Alright, let's get started slowly. So, we said it's a Mercedes-Benz E-Class. This is the Mercedes-Benz E-Class W212. Alright, so we'll perform a full diagnostic to see if the key is even communicating with the system. So let's go to the key section. The IR register means this is where we read the data. So it seems that the primary key to this situation is communicating. However, it looks like the key itself isn't actually the problem here. Alright, then let us go back and re-evaluate. Now we will try to read the ignition lock to see if it is giving us any data or if it is even communicating. So this advanced emulator simulates that the car is right here with us. This process can be done via infrared communication. So we would have to connect the cable here and then use a simulator inside this area so it can read the data from the ignition lock. We'll set the system to automatic detection to see if it will recognize the unit at all. Let's see. So this is a W212 ignition lock. Yes, it has read it. It is a W212. Alright. Now we'll see if it can actually read data from the ignition lock. It can. Good. As far as that's concerned, it has recognized the keys and everything. Good. The next thing we can do now. So we've established that the key should be fine. For now, we'll say that it's fine. The next assumption is that the module for locking the steering column, the internal locking mechanism itself, that little motor, might not be functioning as it should be. To make an emulator, first let's take a look at this device and assume that this is the emulator. We need the necessary data from the ignition locks, which we just read and successfully saved, and we also need the security password for the key. To get the password, we have to go through a process. Now we are making the key. So next we move on to the process of creating the key. We go to the function, add a key to the car. Since we have a simulator, that's always a much faster option for us. Yes, that is correct. At this moment, the system is beginning to read all of the necessary information and data directly from the vehicle's ignition lock assembly. And now it has the data. So now they have to accurately measure the key's frequency, which allows it to be properly calibrated later. Is this a sophisticated Chinese smart key? No, it really is not. Alright, now it's asking us for the new key's data, the frequency. And let's say if this were the wrong frequency, it would immediately issue a warning here that it's the wrong frequency, that the key isn't compatible. Do we have the password? We do not. Alright, so now it's going to start the procedure where we'll have to insert the key into the lock several times. Here it says, leave the key in the lock and wait for 5 seconds. Take it out, put it back in, and wait for 2 seconds. Take it out, put it back into the lock, and then try to rotate it. And then we will move forward into the process of searching for the correct password. Alright, carefully put the key in the lock and wait for about 5 seconds to pass. Okay, that should be enough. Go ahead and take out the key. Just put it back in. Just 2 seconds. Alright, now it tells us to try to rotate it now. Does it actually work? That means, is the lock letting the signal through so it can be turned? It definitely can. Now the instructions say to place it into the infrared reader, and we are ready to get the process started. At this point, the system will begin searching for the security password from the key's memory. So this is a process that can take several minutes. It could be just 2 minutes, or it could be 52. Now that we have got the password, that is very good. We'll make one more test key. We can delete that key, it doesn't matter. If needed. Now it says insert the key into the lock for a full 30 seconds. Okay, let's do that. And then we will need to insert the brand new key into the electronic key programming device so that it can generate a specific and unique data file for this key, which it will then write directly right here into the internal memory of the new key. I had a case where, for example, on the 220 and 203 models, this took over an hour. So of course you have to be careful that the car battery doesn't run out and things like that. This is really a test platform, really a great thing. Alright, that sounds good. Now we'll go ahead and generate the necessary file for the key. Now the screen says to put the empty key into the programmer slot and then press the OK button. We have already done that part of the process. Right now the system is writing the file to the key. It is only at this point that we have finally entered the actual process of programming the key, which involves writing the file to the key. Alright, everything is set up now and it should work correctly, so when you insert the piece into the slot, you will notice there is a red dot right here. It's not really visible on camera. So that little red dot, when we insert it into the lock, it needs to light up and then turn off after a few seconds. And that is it. That means the key has now been successfully programmed. And with that, the process of making the key has been successfully completed. That is looking great. Now that we have the data from the lock, we effectively have the digital password for the key. Now we can finally begin to make. So as you can see, that's the emulator software. Okay, that's the main reason why we need to go here. ESL. It's the Mercedes-Benz W212 model, right here for you to see now. And an EEL file is, as the Germans would say, Datum schreiben. So here, we'll now manually input the data from the lock and the password from the key, so that the whole system should be properly calibrated. Take a look right here and you can see how it is currently glowing a solid red color, which simply means it is not sending out any of the electronic signals that are needed to unlock the steering column for you. Alright, so at this point, we have successfully received the complete data from the simulator. So now we are going to proceed with the next step and perform a systematic sort of the lock data by date to ensure that all our information is properly organized. Then we go ahead and select the file that we previously saved just a few minutes ago from the steering lock, from the lock, from the ignition lock. Alright, Now we need to go ahead and manually enter the password that we saved earlier in the process. Okay, it seems it didn't actually save it after all. Nope. So now we will manually type in the specific password that we read from the key. Here it is, we have it right here now. At this point in the process, you can see exactly how it is currently being programmed. It is carefully reading and writing all of the necessary digital data from both the lock and the key simultaneously. Into the simulator. The message confirms that the data writing process was successful. This basically means that when we put the key into the lock and prepare to turn it, it is currently glowing red. Alright then, that looks good. Now we're going to test it out repeatedly just to see if it will continue turning on and off, on and off. So we have this specific phenomenon where after about 7 or 8 times, the system no longer reads the key. There it is. Now it didn't recognize the information at all. Alright, now that we have finished all the steps, we will test the system right now. Ideally, this indicator should always show a solid green light, and it should turn red normally when we pull it out. That is everything we need to do for now. What that means is that we are going to reach out to the service department right away to let them know that the component is ready for them. We will inform them that they can come by the facility to pick it up at their earliest convenience, transport it over to the workshop, and then begin the process of testing it thoroughly on the car to ensure everything is working perfectly, and that will conclude this part of the project. The next car we have here is an Audi A4, which unfortunately no longer starts. We received another engine computer, and now we'll attempt to clone the data. This unit cannot simply be cloned in a direct one-to-one manner. Instead, the original data and the new data sets must be carefully merged together. But that is not really a major problem for us. Now I will show you the specific problem we are actually facing. The engine starts up quite briefly for just a second or two, but then you will find that you are completely unable to press the gas pedal. I strongly suspect that the real issue lies with the throttle valve itself. But I don't hear the fuel pump at all either. So I'll just quickly show you exactly what I mean. So I'm actually going to try to give it some gas right away. This is exactly how it starts out. The gas doesn't work at all. No. Oh, absolutely nothing works. None of it at all. They also changed the ABS block, but honestly, the ABS block really has nothing to do with whether it's coded correctly or not. I'm just not sure about that. But that actually has nothing to do with it now. It should still start regardless. I also already removed the old module. So this right here is the old one and this is the new one. This is the CMOS 12.1 control module from Continental. So first, we'll have to perform a backup procedure of both modules, and then we need to handle those 4 specific pieces of data, specifically 4 files, not just data. We'll need to merge and combine the 2 flash and 2 EEPROM files together so that we get 1 single EEPROM and 1 single flash from these 2 original files. And then we will write those 2 resulting files into the new one. If the underlying problem is indeed with the engine computer, as they currently suspect, it should work fine after that. For the highly important and critical data, we are going to be using Flex Magic from Motorsport, or as it is more recently referred to as Magic Engineering. It's a top-notch device. I've been using it for years and I'm really impressed. I had 2 instances where I sold the Flex and something wasn't right with it. I got a replacement under warranty. They offer a lifetime warranty on them, and a few months later actually the Flexbox had an issue where I couldn't do boot mode, and they replaced that for me free of charge as well. So both of them were actually replaced for me. No, okay, so it looks like cloning didn't really do anything for us at all. Now, of course, there is a very strong possibility that we simply transferred the existing error from the old computer directly over to the new one. So, what we are going to do now is turn off the immobilizer completely. We will carefully restore all of its original data to see if that fixes it. Let's see what happens next. Could it be that there is a problem with the engine computer's software? So at this point in time, we have completely deactivated the immobilizer system. Now then, if it really is the engine control computer, it should start. This is the moment of truth. No, and you can't give it any gas at all. Alright, nothing. Now we'll run a full diagnostic scan. Now we'll read it real quick to see what it says. Alright, here it is, we finally found the root cause. Why the car won't start? It won't start because the timing chain has stretched out. Unfortunately, the chain has definitely stretched. There were a few different error codes. There was a processor error in the engine computer. That's actually why we came here today, to perform a full clone of the unit. So, after cloning, the situation didn't change. We thought it might be a software issue. We restored the original, did an off in the software, just to rule out the possibility that it wasn't the engine computer. The car still won't start. Initially it showed a crankshaft sensor error, but I honestly thought that wasn't the main issue because the car actually doesn't have a lot of mileage on it yet. The car has, I'll tell you the exact figure, 146,560 kilometers. And unfortunately, it turns out the timing chain has stretched significantly. It's no longer synchronized with the engine, and now it simply won't start at all. It's not sending any fuel to the pump right now, and at this point, who knows what else might be wrong under the hood. Yeah, I know, that's how it is with new cars. Well, I mean with newer ones, actually. The truth is all cars break down. That's just how it is. Yeah, well, I really hope you enjoyed this daily video from the DB Garage. Please follow, like, comment and share. There will be plenty more videos just like this one coming your way. We have a lot of very interesting things going on here. We get all sorts of stuff by mail, and there is always something happening, always some intricate soldering to do. We are constantly fixing, patching and cloning various parts. Actually, the newer the cars are, the better it is for me, because more of those electronics break and fail. So follow, like and share, and I will see you in the very next video.